Good morning. Good morning, everybody. I am Ms. Marita Kotze, Physical Sciences Education Specialist of Impact, and we will start the session now. We will just see and give the learners a few minutes to log into the system. Okay. We are going to wait 2 minutes for everybody to log in, and then we will start. We are still waiting for another minute for everybody to log in on the system. Okay, I think everybody is there. So let us start. Okay. Good morning, everybody. I hope you all are excited as I am this morning. I am Marita Kotze, Senior Education Specialist for Physical Sciences with Impact. If you are struggling to hear me, make sure your audio is on and speak. And your speaker volume is turned up. You will automatically be muted when joining this session. Should you have any questions, you can ask your questions in the question box below or on your right. I am not going to deal with any questions during my session, but I will deal with it afterwards. So make sure that you raise all your questions in the question box, and then I will send it through to you the answers of the questions. So to raise your hand, click the icon on your dashboard below or on your right. Okay, let us just see. Okay, can you see there? Let us see a few hands to see if you can hear me. Tristan, can you hear me? Okay. You can just click on the hand there on the right hand corner. Yeah, you can just see if everybody can hear me. You can just raise a hand for me, please. All right, on the right hand. Right. Yes, there I can see some hands. Thank you very much for that. Okay. Download this presentation and additional resources in the handout box below or on your right. You will also find all this information in the question box below or on your right. Remember to send us your questions. Okay, the handouts, when you download it, after the session, you will see that it is question papers from Dr. Saensha, from the courtesy of Dr. Saensha, and the memorandums will be uploaded on the guided learning platform, where you can download the memorandums later on. Okay, so let us just, we can start. Okay, guys, science gets you places. For you who at this stage wonder why you take a subject like physical sciences, this is Antarctica, and it's a beautiful, beautiful place. And if you love sciences as I do, you can someday, you can maybe also to Antarctica and be a scientist there. Okay, I decided to do term one, the revision of the knowledge areas that we do have, pulses and waves, and electromagnetic radiation. So let us just first look at pulses and waves. Now, what is a pulse and what is a wave? The difference between a pulse is a pulse is a single disturbance, while a wave is a repetition of pulses at regular intervals. We have two different types of waves or pulses. One is longitudinal versus the transverse waves. Now, longitudinal waves, as you can see, are parallel waves, like in sound waves, a little bit later on north of longitudinal waves, and transverse waves. It's looking like a wave. If you think about water waves, if you throw a stone into a pond, you will see there are certain waves forming as well. It's if you think about the sea, you will remember that it's waves that's coming towards you. So that is the difference between the two of them. Now, let us have a closer look to transverse waves. This is a wave that the particles of the medium vibrate at right angles. Now, if we're talking about right angles, then it's perpendicular to the direction of the motion of the waves. So as you can see, it's perpendicular. Let me just see if I can just want to show you. As you can see here, you can see there's a perpendicular movement. Examples that we do have is water waves, waves on a string, and radio waves. What is an amplitude? An amplitude is the difference between a crest and the end point or the middle point, or a trough. As you can see, there's a trough and the middle point. So that is an amplitude. What is a wavelength? A wavelength can either be from this point to that point, it's one wave, or from a trough, from a crest to a crest, or a trough to a trough. So it depends on how many waves. If we count the waves in this sketch, we can see there's one wave, there's another wave, and there's another wave. So we do have three waves here. Two other things that you need to know and understand is frequency and period. Now, what is the difference between the frequency and the period of a wave? The frequency will be the number of waves per second. So, say for example, these three waves would form in 1 second, then the frequency is this. There are three waves in 1 second. The period is the time taken for one complete wave. So for one complete wave to pass this point is then the period, and that will be 1 second divided by 3. So it will be 0.33 seconds if we think about it like that. Okay. Now, longitudinal waves is a wave in which the particles of the medium vibrate parallel. As you can see, it's parallel, and we do have compression or rarefaction. Rarefaction is where you can see that they are further away, and compression, you can see it's where they near each other. The wavelength will be from, again here, from the middle point of a compression to the middle point of a compression, or middle point of rarefaction to the middle point of rarefaction. The direction of travel is to the right, and movement of air molecules. Remember, if we think about longitudinal waves, we think about sound waves. So what is the compression? The compression is a region where there is of high pressure, and rarefaction is where there's low pressure. It's also the maximum displacement of a particle in its rest position. Can you see it's a maximum displacement? The biggest the biggest displacement is during the rarefaction. Good. Now, frequency and period. As I stated earlier, you can see here that we have 1 second, and there are 1, 2, 3 waves in this sketch. Okay, so we have the number of waves we do have here is of 3, and the total time will be 1 second. I will do the calculation we will do on the next page. The period then will be, again, it will take, if there are 3 waves as we see here, there are 3 waves in 1 second, then it will be from 1 wave will be in 0.33 seconds. What is the relationship between frequency and period? We can calculate if there is a inversely proportional. Period is equals 1 over f over frequency, or frequency will be 1 over period. Let us just see the difference in calculations. If we have the period, determine the period of a wave that has a frequency of 75 Hertz. You can either use 2 formulas. It depends on what you do have. Okay, if you do have the frequency, it's easy. You can just use your formula T equals 1 over F. But if you don't have that and you have the number of waves and the total time, then you use your formula period equals total time over number of waves. You will find in many question papers they will either give you the one or the other one, but remember this formula that we have here is not on your formula sheet. The formula sheet you receive during a test or a question paper, you did receive attached to your test paper, you did receive a information sheet. Make sure that you take that information sheet and write all the formulas that's not on the formula sheet that you know you need to learn. For example, this one that's not on the formula sheet. Write it down in red, learn it so that you do know that you need to learn that additional. Okay, frequency therefore will be, again, you can either use the formula frequency equals 1 over period, or frequency equals the number of waves during the divided by the total time. In this particular time, it's determined the frequency of a wave that has a period of 0.3 seconds, and then you will find that it's 3.33 Hertz, or you will have 8 waves pass a point in 3 seconds, and the frequency will then be 2.67 Hertz. Okay, are you still there? I hope you can hear me still, and if, let me just show a hand. Keegan Loxton, can you hear me? All right, I just want to see. Just show a hand so that I can see that you can hear me. Zanet Hudson, can you hear me? Okay, I assume. Okay, there are many hands. Goody van Silent now. Thank you for that. So you can hear me. Thank you very much. Okay, so let us just look at the other thing, wave speed. What is wave speed? We do have waves now, so if there are waves, there must also be wave speed. So the wave speed will then be the distance a wave travels in 1 second. We do have the waves, and now we see that they can travel in a certain time. So how do we calculate wave speed? We can calculate wave speed either with the speed equation or with the wave equation. It depends again on what you do have. Okay, if you do have the distance and the change in time, then you can calculate the speed using this formula. But if you do have the waves, a certain amount of waves, you will see that they can combine the previous calculation where you do have to calculate the frequency and then calculate the velocity of the speed. You can use this formula. So remember, write down what you do have, and as we did here. The example that we have here is it takes 0.2 seconds for a pulse to cover a distance of 300 millimeters. What I prefer is where you do have a question like this, highlight what you do have. For example, highlight the 0.2 seconds, highlight the 300 millimeters, and write down on the left-hand side on your paper, write down what you do have. What is asked and what you do have. You do have the distance. By writing it here, you know that your unit for distance is in meters, so you need to convert the millimeters into meters. Do it then while you're writing it down, so then when you're doing the calculation, you don't have to do it here. So make sure that you make the conversions before you start with your calculation. You always start with the formula, the substitution of the formula, and then you have an answer that's a unit. Learners, please make sure that you do know the units of all the different calculations, because if you don't have a unit, there's no marks awarded for a calculation, for the answer of a calculation if there's no unit. So make sure that you do have a unit with it. Now, in the case of where you do have the frequency, then you can use your formula V equals F frequency multiplied by lambda. Sorry, you can see here the wavelength just moved here. So make sure that you it's 600 multiplied by 0.02, and your answer will be velocity equals 12 meters per second. Okay, this also moves a bit, so sorry for that. All right. Okay, now what is superposition and interference of pulses? The superposition of pulses are the algebraic sum of the amplitudes of two pulses that occupy the same space at the same time. So for example, if you do have an amplitude here, you can see that it's superposition, it's 18, it's 10 plus 8, its superposition is now 18. All right, interference. We do have two types of interferences, namely constructive interference, destructive interference. Did you ever notice when you are at the seaside, you sit and you look at the waves, you will see that there can be two waves from different sides. And when they interfere, they can either improve or make the amplitude larger of the wave, or they make it smaller. If they connect each other, the rest, or a crown and a crown, or a trough, a crest or a crest, or a trough meet together, then the amplitude is larger. Then you have a constructive interference with a much bigger wave. While in destructive interference, if a trough of one pulse connects with another with the trough and the crest, when they move together to each other, then they have an amplitude that is smaller. They distract each other, they will have an amplitude that is smaller. And afterwards, after beating, they just move apart again. Okay, so then we have a destructive interference, and then we have a constructive interference. Okay, now sound waves. Sound waves, many of you may be playing guitar, and while playing guitar, you will feel there's a transverse bass if you're busy playing on the guitar. But why do I hear, or can I hear what you are playing or while you are playing? It's because of the longitudinal waves that move to my eardrum. Okay, on an oscilloscope, we can see the longitudinal waves as a sinus wave, but it is, as you can see here, we have the compression part of the sound particles and rarefaction of during that time that we do have here. Okay, now so why do I hear you? It's because of vibrations, and the vibrations turn into longitudinal waves, and that's why I can hear you then. So there are two different things that we do have with sound. We have a pitch. Now, I don't know about you, but if a dog barks with a certain pitch, it can be so annoying. So yes, it depends on the pitch, if it's a lower pitch or a higher pitch. And that is directly proportional to the frequency. Frequency is, say, for example, 600 hertz or 200 hertz. It depends on the higher pitch or a lower pitch. While the loudness is if the dog barks just next to you, then it's very loud. It can bark with a high pitch and it can be loud, so then it's very annoying. So if the loudness is directly proportional to the amplitude, here you can see the amplitude is small, then it's lower, the sound is quieter, and if the amplitude is bigger, it is a louder noise that you can hear. All right. So yeah, please remember, for learners who join us a little bit later, I can see there are more attendees now. Just the following, I'm not going to answer any questions during this session. I will answer it afterwards. You can just write all your questions for me in the box. You can see to the right, to the bottom. You can see there on the right hand side. You can see there's a box where you can write all your questions. So please write your questions if you do have any, so that I can attend to it afterwards and send you the answers. Also, there are some handouts. The handouts that we do have there are question papers regarding the topics, the sections that you cover in term 1, and the memorandums will be loaded onto guided learning platform, where you can download it. Now, electromagnetic radiation. What is electromagnetic radiation? We do have waves and we do have particles. Why? Because electromagnetic radiation behaves like waves or like particles. Now, if we look at this, we will see that it is oscillating magnetic and electrical fields move at right angles with each other and to the direction of propagation of the wave. Here you can see the magnetic field, the electric field, all three of them, and the traveling direction, they are perpendicular to each other. So here again, you can see the length of a magnetic wave. The blue, can you see? And the red, can you see? So we have an electric field, the red one. We have the magnetic field, blue one, and the traveling direction of the wave is to the right. Now, what is the particle characteristic of electromagnetic radiation? Electromagnetic radiation transfers energy to other matter in packets called photons. Now, if we look at the sketch that I do have here for you, you will see that here is a piece of sodium metal. Now, light shining on clean sodium metal in a vacuum. If the light, if this is a specific light, and if the light frequency is high enough, then electrons will escape from the metal surface. Now, how can they escape? When we get to the chemistry part of today's session, you will see that there are electrons in the around the atom in the outer energy level. Now, the electrons in the outer energy level, if there is an increase in kinetic energy to that electrons, they can be ejected from the surface. Okay. Now, in order for them to be ejected from the surface, there must be energy. So what energy? We say in electromagnetic radiation transfers energy to other matter in packets of called photons. And these photons or particles of light carries a quantum of energy. And that quantum of energy enables the electrons to escape from the metal surface. In grade 12, we learn about the photoelectric effect, but a little bit, that is grade 12, so you learn this in grade 10. As long as you know what is electromagnetic radiation, you will do the application in grade 12. Remember this when doing grade 12. Okay, as it is, you will see that we do have work in grade 10 and 11 that needs to be, that you need to know or need to learn for grade 12 as well. So here is the different electromagnetic waves that you get, that we have. There's only a few here that I put in on here for you. Electromagnetic radiation spectrum, you can see the different ways that we do have: gamma rays, X-rays, ultraviolet rays, infrared. Now, as you can see here, is an N before the M. The N stands for nanometer. I'm not sure if you do know all the abbreviations, so please make sure that you learn the abbreviations. There you can see nanometer, it's 10 to the minus 9. Here we have centimeter, 10 to the minus 3. So please make sure that you know what the different abbreviations stands for. Okay, as you can see, the spectrum varies from gamma rays, X-rays, ultraviolet, infrared, radio waves. And there you can see the different radar, TV, FM, AM that we use the most during the daytime. Okay, so let's just have a look then. Matter and material. So, guys, I know matter and materials, chemistry is not the favorite of many learners, but it's the most exciting part of physics and of physical sciences. I love it. Physics and chemistry both are my passion, but chemistry, because you can visualize, you can see, you can do the practical. So let us just have a look at the basic chemistry concepts and atomic bonds. All right, so that's why I put this for you here. Why do you think we need to know chemistry? Just by eating bread each day is a chemical reaction. When your mother, especially now during the lockdown, baking your bread is a chemical reaction. Drinking water is a chemical reaction. The air that you breathe is a mixture of gases. That's chemical. That's things that you need to know. Um, the fertilizer you throw in the garden, that's a chemical substance. So yeah, chemistry is all around us, not only physics. So make sure that make it very exciting for yourself. On this note, I just want to ask from the learners and everybody that's listening here is that not look just at the chemical reactions that you need to do during the year. In your study guides, there are many uh, practicals that you need to do. Not all of them are compulsory. So, but if you can try to improvise, it's not necessary to have all the equipment. I know it's difficult to get hold of the chemicals. Therefore, I put some information for you on your study notes that you can download from my impact. Make sure that you did download it, and if you didn't, make sure that you download it today. There are information of Somerset Education where you can order chemicals from. They do have it in small quantities. It's not expensive. Start to do some practicals. Physical sciences are a practical subject. So please try to do experiments. If you don't have the chemicals, I also put a put in the notes the information on PET simulations, where you can use PET simulations to do very nice circuit diagrams, electrical circuit diagrams. If you start, it's a program that you can download for free from the internet, and you can just start to play around, do some practicals with it. It's very, very nice. So, all right, classification of matter. We have pure substances and we have mixtures. Now, pure substances have a definite composition, while mixtures are of variable composition. So, a pure substance and a mixture. So, for example, a mixture with you can see if you have water and sand, that's a mixture. You can see the water and you can see the sand. But a pure substance like water, it's a definite composition of hydrogen and oxygen. That's a pure substance. Right. We have our pure substances are either elements. Now, everything around you consists of elements. One or two elements. The gas that you breathe, oxygen, is a diatomic element. Nitrogen gas is a diatomic element. The compounds, the water that you breathe, you can see the different molecules. An atom, when it, like for example iron, it's only atoms. There you can see it's one atom. Combination of different elements have one. Here is two or more. Where there are two or more elements, we have compound, and it forms a molecule. Homogeneous, uniform throughout. Can you see here? You have a homogeneous mixture and a heterogeneous mixture. A homogeneous mixture is where it's in the same phase. Heterogeneous is there are distinct visible parts. For example, water and sand. It's a different parts. Okay, so pure substance it can be classified as either elements or compounds. Our elements, as you can see here, is, for example, neon, molecules, oxygen, when we have compounds, the molecules, for example, hydrogen, this molecule here that we do have is a diatomic element. It's because it's in nature, its natural form. It consists of two oxygen atoms that covalently bonded together as a gas molecule, but it consists only of oxygen. That is a diatomic molecule. All right, so here we have compounds. Sodium chloride. Sodium chloride is normal table soap that you find in your kitchen. So, and it consists of ions, and ions consist of you do have a crystal lattice. So we have here molecules like water and crystal lattice. This is solid, this is a liquid. Now, compounds are formed when atoms of two or more elements are combined chemically and not mechanically. So make sure that you know that your compounds are combined chemically and not mechanically, like water, for example. So now, atoms and molecules. What's the difference between atoms and molecules? An atom, as you all know, an atom is the basic part of all elements. It forms the basic part of all matter, for that matter. And while molecules of an element consist of two or more atoms. For example, oxygen and oxygen atom gives us a oxygen molecule. Here we do have a hydrogen atom and the hydrogen atom and the oxygen atom to form a water molecule. So then the difference between atoms, molecules, diatomic molecules, compounds, and mixtures. So here we have an atom, and you see there are only one single atom, for example, neon gas. And here you do have oxygen diatomic molecules. Then we have ammonium gas. Ammonium gas consists of three hydrogens and one nitrogen, as you can see here. And then we have a mixture. Here we have a mixture of neon atoms, oxygen molecules, and ammonia gas. So here you can see all three of them are combined in one container. So what is the general structure of an atom? Now learners, this is the most important part to understand in order to understand the periodic table, because all the elements on the periodic table do have consists of elements, and each and every element starts with one atom, and it depends on the amount of or the number of protons and neutrons and electrons in the atom where on the periodic table you will find the atom of this specific element. Okay, as I state, you do have in the core, the nucleus, you do have two particles. Now the red particles are the neutrons, the blue positive particles are the protons, and the green particles that you do find around in circles, these circles are energy levels. The electrons are moving around in these energy levels. Can you see that? Notice here that we do have in the first orbit or the first energy level, there are only two electrons. The next energy level have more, and the next energy level have more. So remember that you must know the structure of an atom, know how many electrons moving around in the energy levels. All right, the neutrons are uncharged, but the protons and the neutrons are the ones that form the mass of the atom, of the element. So that's why they are like sitting ducks in the core, in the nucleus, dust, like sitting ducks. Okay, so here is the periodic table with all the elements. If we look at hydrogen, hydrogen is number 1 on the periodic table. So hydrogen is number 1, helium is number 2, lithium is number 3, and so on. As you can see here, we have, according to this periodic table, we do have 18 groups. The old periodic tables do have 7 or 8 groups as well. We use the Roman numerals for that. We can see here we have the periods. Now the periods, and you see 1, 2, 3, 4, 5, 6, 7. These are the periods. Now the periods are, as you can see here, the horizontal line on the periodic table are the periods, and the vertical columns are the groups that we do have here. Now, hydrogen do have only 1 electron in its outer shell. That's why it is number 1 on the periodic table. Helium does have 2. Now, as we look at the previous slide, we can see there can only be 2 electrons in the first energy level. So that's why helium is happy. He's happy chappy because he is in group 8. He's a noble gas. All the elements in group 8 are noble gases. Okay, they are stable because they have the correct amount of electrons in the outer shell to be stable. And all the other elements of the periodic table are a bit jealous about why, because they are stable and the rest of them are not. Okay, so all of them try to be stable noble gases, and that's where we find bonds. A little bit later on, more about bonds. Okay, so here we can see that the elements on the periodic table are in certain order, and the order that they are in is according to the atom number. The atom number states the amount of protons in the nucleus. Okay, and if we do have the number of protons in the nucleus, then we know we will also have a number of electrons that's running around in the energy level. Okay, what is very interesting, you can see here the number of periods that we do have here. The number of periods states the number of energy levels of each atom. So you will find that a potassium atom will have 4 energy levels with 1 electron in its outer energy level 4. Very interesting. So the first 3 energy levels will be completed in all the correct amount or number of electrons, but just 1 electron in its outer shell. So while calcium will have 2 electrons, but also 4 energy levels. Okay. All right, atomic bonds. So that's where we find atomic bonds. If we look at the periodic table, let us just look at covalent bonds. All right, as I said, everybody wants to be a noble gas. Group 7, they have, all the elements in group 7 have already 7 electrons. It's 7, but also group 70, so it has 7. All of them do have 7 electrons in their outer shell. So what is happening here? They will not give away any electrons. So they will either share or they will take away from somebody else. So in a covalent bond, you will see a Cl2, chlorine gas. bromine gas. All these, the colors, can you see they are the same? All of them, they are gases. They are diatomic gases as well as hydrogen. So the natural form in the universe is diatomic. Okay, they are diatomic gases. So nitrogen is N2, oxygen is O2, F2, Cl2, bromine 2, and iodine is I2. So all of them, they combine covalently. So our covalent bond will be between non-metals. All right, here you can see we have carbon. Carbon do have 1, 2, 3, 4. Carbon is in group 4. Group 4. 14 and 4. Can you see 1, 2, 3, 4? Carbon do have 4 electrons in its outer shell. So each carbon will need 4. So by sharing 1 electron with the other carbon, there's already one of the shells. So it needs 3 more. So there you can see a hydrogen bond with a hydrogen bond and a hydrogen bond. So they are covalently bond around this one here. On the other side, again, we have a covalent bond with this carbon atom. Carbon is happy because he thinks, okay, I do have 8 electrons in my outer shell. Hydrogen is happy, each hydrogen is happy. I do have 2 electrons, so I'm having a more stable outer shell. All right, what's happening with the ionic bond? Ionic bond, if we look at our metals and our non-metals. Our metals, group 1. Oh my goodness, only 1 electron in the outer shell. Group 2, 2 electrons in the outer shell. It's far from 8. So what will happen with our metals? Our metals will gladly give away. Why? Why will they give away? By giving away 1 electron, they will have the previous noble gas structure. Lithium will not become helium. No, not at all. Lithium will have a helium structure and it's noble. But by that, it will be lithium 1 positive. That's an ion. If I give away, I lost something. Now the metals lost electrons. So by giving away electrons, they all become positively charged. Our non-metals, on the other hand, they say, no. I will not give away, but I will gladly take your electron. Okay, so chlorine, for example, in stable salt, chlorine will say, just give it to me, I will take it. Okay, and in that process, chlorine is negative, sodium is positive, and they can combine in a crystal lattice. So just let us look again. What is happening here at sodium and chlorine? Sodium is neutral. It's a solid. Sodium is a metal. It's a soft metal. Right? It's a soft metal. You can cut it with a knife. It's a very shiny metal. Now it must turn into something else in order to combine with chlorine to give us stable salt. Chlorine gas. Did you ever smell chlorine gas? When your father threw a lot of chlorine into the swimming pool, there's this horrible smell. That is chlorine gas. Okay, do you think you want to eat that? By combining that shiny metal and that green gas that smells awful, you got stable salt. That is luckily something that's happening in the earth. So we have Himalayan salt, salt crystals. They're forming for many years. They're forming fossils. So they form, and we can get some salt from the earth. Very nice. There's salt in seawater. So what is happening here? in order for them to turn into stable salt, sodium lost its electron. Give it away. And chlorine said, thank you very much. I'm taking that electron. And in that case, I do have now 8 electrons. Sorry to hear about you, sodium. You do have now maybe what structure do you have? You have the structure of neon. But you're not neon. Sorry for that. But yes. So what is happening here? It's a positive ion, and the positive ion and the negative ion can combine to form a giant crystal lattice, becoming the stable salt that we eat. Okay. These two ions are attracted to each other by electrostatic attraction forces. On the other hand, we have the metallic bonds. Sodium, that shiny, soft sodium, it's soft because we have a sea of delocalized electrons and atomic kernels. What is happening? Valence electrons become delocalized, and bonding force is the Coulomb attraction between the negative sea of electrons and positive atomic forces. So what is happening? The electrons in the outer shell, the reason they do have 1 or 2 or 3 electrons in the outer shell, so they will happily get delocalized. That's why copper is a very good conductor, because there are delocalized electrons we do transfer the energy in. Okay, now the last thing that I want to discuss with you, our time is nearly up, are the 3 things that's very important to me. As I said previously, you must know that you need resources. Okay, there are resources. We put some resources on My Impact for our learners. There are resources on guided learning, but there are also a resource with the name of the Quanta book that you received this year. That's part of your package. For the learners that are not registered with Impact, I put an email address on the notes after this. I put an email address on it where you can order the Quanta books from. More about that now. And learners, the science clinic notes, very, very useful notes. So let me just show you. Okay, Doc Sciential, we use Doc Sciential's textbooks. They also do have all the practicals on a memory stick. If you don't have apparatus at home and you want to see the practicals, very important. That's very nice. They also discuss the scientific reports with you, in state what is the hypothesis, what is the investigative question, go through it time and time again. So very useful tool. You can buy some past papers from them. You can buy exercise books from them, as well as the memory stick with the practicals on. Here's the Quanta books. The Quanta books do have 2 DVDs with each Quanta book. You will receive 2 DVDs, and on these DVDs, there are a total of 8-hour lessons where you can listen and look. It's a qualified science teacher, very qualified science teacher, explaining the main concepts of the work. It's in Afrikaans and in English. And then in the text, in the summary book, you will have summary as well as questions, numerous questions on each topic with the memorandum at the back of the book. Okay, and then lastly, the science clinic notes. You can download it from free. As you can see, learners, this is very, very useful. You can download it for free from the website. Compact notes with explanations and examples of each topic, and they also do have exam seminars during the year where you can register on their website. There's certain venues. You make sure if you're an impact learner that you use and state that you are an impact learner when going onto the website and want to register. Okay, guys, that was a lot for today. I hope you will find this useful, and I certainly want your feedback on this session. Feel free to give me some feedback as well. What else you need to discuss, with you, and good luck with the rest of the term's work. What do you need to do now in this term? Very important is the balancing of the equations, magnetism, electrostatics, and electrical circuits. That are topics that I will cover in my next webinars. So make sure that you download this PDF document, go through the webinar. If there are any questions, you can send me an email as well, or just write your questions so that we can contact you and answer your questions. Thank you very much.